Greetings all, Timberlake here. Today I'm going to show you how to solve a diabolical Sudoku puzzle. I pulled this puzzle off of printmysudoku.com from the grids of the day, February 18th. It's called Diabolic Puzzle 6151. With that, it's solving time. First thing I'm going to do is show all the candidates when I'm solving a harder diabolic puzzle. I will show the candidates. That's the only way I see, because I'm trying to eliminate candidates. I'm not trying to solve the cells outright, because you'll need advanced strategy techniques. Looking down here, 1717, that has to be an 8. The other thing you'll notice is it will lead to solving the cells pretty easily in the beginning. Okay, so the 5s have to be in row 7 right there, so that 5 can be eliminated. That can be a 1. This is a 7, that's a 1. This is a 6, that's a 2. Here's a 1, 9, 7. All those are naked singles. We got a naked single 9 up here. 4, 8, 4, 5, 4, 5, 8. That's a triple. So we can get rid of that 5. This is with a 3, 6. A locked pair down there. Now moving up. Here you can see there's many more candidates, and it's going to be really hard solving that middle, because the middle starts out blank. That's where our focus is going to be, and I'm sure that's where the harder strategies are going to come into play. So I see 2 3s here, and 2 3s here. Okay, one more 3s. 2 5 2 4 5. And the 2s can't be in anywhere else. So I actually can make a pretty early unique rectangle elimination. So probably the best way to show this would be to show these 2s. So you can see here, for unique rectangle, what we need is 5-button BVCs, at least one. So we have 2 of them. 2 5 2 5. They're in, and then there's another 2 pair that also has 2 5 in there. Looking at 2 rows, 2 columns, 2 blocks. So for unique rectangle, we assume that this solution is unique. So there's going to be one solution to the puzzle. And that's how unique rectangles work. In this case, if we put in a 5 and then a 2 here, then this could be a 5 and this would be 2, and we solve the rest of the puzzle, come back, well, it might also, you'd be able to put a 2 and then a 5 and then 2 and then a 5. 2 solutions can't have that. So we know that one of these cells up here, it can't be both. It can't be like a 2 and a 5. It's got to be one of these other numbers. Well, the 2s only appear in the 4 cells. They don't appear outside of it. So the 2s have to be in some kind of X-wing formation. The 5s don't, because the 5s appear in the block. They appear in the row, appear in the column. I believe this is a type 4 UR. So what we can do is we can actually eliminate the 5s from these 2 cells up here. So I'll get rid of that 5 and get rid of that 5. They can't be the solution to the puzzle. All right, moving on. I can actually go into, well, I'll look here first to see if there's any other hidden singles. So we have a 6 there. We have an 8 here. We have a 2 here. Okay, so I don't see any more hidden naked singles. Oh, it's a 5 and 7. 1 9 1 9 1 3 9. It has to be a 3. These 3s we can eliminate 3s from the rest. We are able to do that. Okay, the 7 can be there now. So 7 7 7 7. Yeah, that's another 7, and the 7s are taken care of. 4 6 8 and 1 5 9. There's 2 separate triples in there. It's good to note. All right, I'm going to go to the highlight. Feel we can make some pretty quick eliminations that way. I'm filtering the candidates by the ones. Don't see anything I can eliminate at this point. The ones, the 2s. Yep, I missed one of those naked or hidden singles. Okay, moving on to the 3s. 1 3 1 3 1 3 1 3. We're going to be able to make some more eliminations. So what we have here, and this is a gotcha. When you're doing these eliminations for a unique rectangle, you have to consider the 2 that are in the same block. You can't go 1 3 1 3 across the top and then try to make eliminations off the bottom 2. It's only going to be working like this way. So what I'm saying is you can't, right now I wouldn't be able to just eliminate the 3s from down here and down here. That would be a little premature. Don't want to do that. So instead what we have is more, let's see here, 4 6 9. Yeah, instead what we have here is, I'm going to treat it as just a type 7 unique rectangle. So this cell right here, what you do is you look at the one that's that's diagonally opposite of it. And what we notice is that 3s can't be anywhere outside of these cells, so that we can actually eliminate the 1, because the 1 could appear somewhere else. And we're, and if the 1 was the solution here, that'd violate the uniqueness. Oops. See, if you do that, it's like, hey, that's not the solution. So why click to eliminate the candidate instead of trying to fill it in? Okay, and what does that do with our 1s? Now, makes 1s across the top, across there, 3 4 6 3 4 6. Can't make any more eliminations that way. But we come down here, another unique rectangle, 3 6s. Well, guess what? We can eliminate the 6. Excuse me. And I did it again. I am trying to solve for a 6. I just told you it can't be a 6. You can like both of those 6s, which leaves the 6 in the row is the only 6 available. And there you go. And then we have our 4 8. All right, 4. We have the 4s across the top. And the eliminations also I can make with the 4s. That is a naked or hidden single 5. And else I can solve with the 5s. Going to the 6s. Eliminations with the 6s right now. Like you can consider another unique rectangle with the 4 6 here and here. However, since this can also be 4 6, both 4 and 6, doesn't qualify as a unique rectangle at this time. And this is the only 9 in the row. Solve this 9, that 9, and that 9. So the 9s are taken care of. So we've made substantial progress with those unique rectangles. 4 8 4 8, that has to be a 3. 4 5 4 5, we can eliminate the 4 and 5. 4 there. So 1, 3, 3, 6, 1, 6. 4, 5, 4, 5. That has to be an 8. That's a 4. You know, we're getting pretty close to solving this. In fact, again, with uniqueness, I can tell you that that is a 6. Remember we eliminated the 1 earlier? Well, then it would have been a type 1. If we had the 1 back in there, it would have been a type 1 unique rectangle. 1, 3, 1, 3, 1, 3, 1, 3, 6. And to avoid uniqueness, this has to be a 6. That's 4, that's 1, that's 3. That's 1, that's 3. This puzzle is pretty much cracked. When they're talking about diabolical, sometimes it can be very, very hard. We did have to use a lot, several unique rectangles to solve this one. But once you get the hang of a unique rectangle, you can see that cracking these can be relatively quick. Sudoku's been solved. What'd you think? Did you try something different? What kind of strategy did you use? Let me know in the comments below. Please don't forget to like, share, and subscribe. Hopefully, using these videos will help you see and enjoy Sudoku as much as I do, make it a full-time hobby instead of just a passing interest. Thank you so much for watching.